So now we're going to really talk about acute triangles, right? That's what this entire unit is about. Acute triangles, right, Matt? Right? What is an acute triangle? Triangles that have angles all smaller than 90 degrees, okay? Now, you cannot use SOHCAHTOA, sine, cos, and tangent, your old way. You can't use it because there's no right angle in acute triangles. So you can't find the hypotenuse because there's no 90 degrees. So you can't use sine, cos, and tan like you have in the past. So what happened is some amazing mathematicians figured out a way of solving acute triangles using new ways. Christina, can I get you to shut down the lights so everyone can see? Because I know it's hard to see without the lights off. Okay. So let's say we're given a triangle that contains no right angles. So triangle ABC. Okay? So you've got triangle ABC. What I'm going to do is I'm going to show you how the law of sines came about. Will you ever have to do this proof in Math Foundations? No, you physically won't have to show this proof to me. Okay? But some people need to know how this formula works. Okay? And I like to show it. Because later on in life, sometimes you have to do proofs, like our last unit, which is Unit 1, is all about. Some deductive and inductive proofs, I think. So we've got this triangle, ABC. What I did was I made this line here. Good. What's that line contain? A 90-degree angle. So we now cut triangle ABC into two smaller triangles, ABD and ACD. Okay? So I have this small triangle here, ABD, and I have this triangle, ACD. And now I can solve a few things. So in triangle ABD, if I want to know angle B here, I can write sine B is equal to opposite over hypotenuse. So let's look at that triangle. I want to have a pen here. So in triangle ABD here, if I'm looking at angle B, what's the hypotenuse side? Hypotenuse is side C. And if I'm going to use sine, what's my opposite side? AD, this height, right? So the height of the triangle is the opposite. So I'm going to fill into my formula here. Sine B is equal to AD, my opposite, over my hypotenuse side C. Okay? And so I put it over 1, and I just cross multiplied, so I got C times sine B is equal to AD, the height of the triangle. Thanks. We're going to do the same thing with the other triangle. So we're going to use sine like we used to with the other triangle. So the other triangle is over here, ADC, right? And we're going to look at angle C. What's the hypotenuse of this new blue triangle that I drew? B. So this is my hypotenuse over here. And what's the opposite? AD. So it's the same thing. So the opposite side is the same thing for those two separate angles. So the sine of C is equal to AD over side B. So if I cross multiply, I get B sine C is equal to AD. So now I have C sine B equals AD, and I have B sine C equals AD. If they're both equal to the same thing, they're equal to each other, right? So if I said angle A is 35 and angle B is 35, you tell me angle A equals angle B. This is the same thing. I'm saying that C sine B equals to that length AD, and B sine C equals to the length AD. Before we move on, does anyone know why there's lowercase letters and big letters? Anyone know why we use lower and bigger letters in triangles? The lower letters are equal to side lengths. The big letters stand for the angles. Okay? So this is side length B times the sine of that angle measure C. Okay? Now AD is a side length too, right? But it's measured from the middle and it doesn't have a real angle to go across from. So side length C is always across from angle C, and side length B is always across from angle B. Okay, so you get the name of that side length as a lower letter because it's across from that angle. Okay, I forgot, you might not know that. So now we're going to set both of those two things to equal. C sine B equals B sine B. So then I divide it by sine C, get B alone. And then I divide it by sine B on both sides to get sine B on that other side. Okay? To create the sine law. That's just how they came up with it. Are we okay with that? Right? It's just how they came up with it. It's the reasoning or the backing behind it. So we now know that the sine law is actually true. It's equal to each other. It works. What am I expecting you to do in Math Foundations? To be able to use the sine law. Okay? So you won't actually have to go through this whole step. Then I prove the sine law to you. We're going to go and look at the sine law now. Okay? They went through and proved it for the other angle as well. So this bottom thing right here, that is your sine law. Okay? Side length A over the sine of angle A equals side length B over the sine of angle B, which is also equal to side length C over the sine of angle C. Okay? So let's get using it. Are you okay with that? Can I show you how to use it? Okay. It can be written both ways. So A over sine A equals B over sine B. It's equal to C over sine C. Or it can be written as sine A over side A equals sine B over side B, which is equal to sine C over sine C. As long as the side lengths are either all on the top or all on the bottom. Okay, you can't mix them around. Okay. Now, what's awesome about the sine law is you only need 2 out of the 3 things. So if I know side A and angle A and side C, I can find angle C by just using A over sine A equals C over sine C. So you don't need to use all 3 of them. You need to use 2 with an equal sign between them. Okay? So let's use the sine law to solve for these things. The first thing I would do is I'd label a triangle. Okay? I like labeling triangles ABC all the time, but some people like to get funny and label them as cat and tan and Pat and Rob and any 3-letter word they can think of. Okay? But you can use ABC all the time, or you can use random letterings. Okay? From your textbook. So we have triangle ABC. So the first thing I'm going to do is I'm going to write down everything I'm given. Am I given angle A? Okay, so angle A is equal to 53 degrees. Am I given angle B? No. Am I given angle C? Do you? So which one do you want to do? The one on your sheet? Okay, so what's changed? I hope it works. I don't know. Sometimes you throw numbers out there and sometimes it's not a real triangle. Okay? So hopefully yours was switched properly. So it's 12 and 62. So I need to come back here and change my angle C. It's not 41 anymore. Okay, no eraser. That's 62 degrees. From your thing, right? So, how do we decide what side lengths we know? Depends on which angle we're using. So this X, what side length is it? It's side length A. So I write lowercase a equals X. I knew it was lowercase a because of the fact that it's across from that angle, right? And which one's lowercase c? 12, because it's across from that angle, right? All you need for the sine law to work is an angle and a side measure that matches, and another angle and a side measure that you know one, but you don't know the other. So I know all of A's. No, I know one of A's, and I want to know another one of A, and I know both C's, the angles and the sides. Okay? So then, all you have to do is write down your sine law. Okay? Now, the sine law has 3 statements, but we're only using A's and C's, right? So I'm going to say A over sine of A is equal to C over sine C. Okay? So you only need 2 out of those 3 statements. Okay? Then you fill in. So what goes in for side A? And what's the angle of A? Sine of 53 is equal to side length C, which is 12 over the sine of 62. Okay? Now, what does this look like for you guys? Yeah, something we know. Line equals line. Perfect. Okay? So how do we solve line equals line? Cross multiply. Okay? So we get x times the sine of 62 is equal to 12 times the sine of 53. Okay? What do you want to do next, you guys? What do we want to do next? Okay, some people might want to right away divide by the sine of 62. Anyone want to do that? That's the first thing I would do. Some people would want to get the numbers, like find out what sine of 62 is, write that number down. Find out what the sine of 53 is, write that number down. You can do that, that's fine, but then you're going to have to enter that into your calculator. So that's a lot of numbers to enter over and over again. So what I would try and do is try and get x alone first, if you can, and then enter it into your calculator. Okay? So I'm going to pull up my calculator here. Maybe if I have a mouse. Okay. So I'm going to go 12 times the sine of 53. Okay? Some people will just find out what 12 times the sine of 53 is and hit enter. That works. So the sine of 12 times 53 is 9.58. That's what this is. And then you have to divide by the sine of 62. Divided by the sine of 62, end bracket, gives me 10.85. Okay? Now, the original question just went to the ones. So 10.58 or 10.85, that would round to 11, and that would be fine. Some people would write 10.9. I'd be okay with that. Okay? So x is that side length, which is 10.9. And so sometimes you have to figure out more side lengths, so you'd actually have to come up here and write 10.9, and you might have to solve for other angles or other sides. How much you solve for angle B, you guys? Good. Don't lose what we learned last unit. What he said was 180 minus 53 minus 62 to get that third angle of a triangle. Because no matter what, all triangles, whether they're cute or not, I shouldn't call them cute, acute or not, they add up to 180 degrees in the interior angles. Okay? We good? How do you guys feel about the sine law so far? Easy. That's good to hear. My mouse is acting up today, you guys. I can't find him. You see him? Ah, there he is. So we're going to move on to the next question. Maybe. I don't know what's going on. So in our second question here, they actually labeled the triangle for us, right? We have triangle ABC. And so what I do is I always write down what we're given and asked to find right away, okay? So what do we know? Nicole, what's one thing we know? Angle C equals 48 degrees. Perfect. Jesse, what's another thing we know? Good. Little c, side length of c is 10.3. Demara, anything else we know? Side length A as 7.2. And Morgan, what's the last thing that we're asked to find? Angle A is equal to x. So now we're solving for an angle measure. So slightly different, but it's still we're using the sine law. So we take both A's and C's out of that sine law and write them down. So I'm going to write A over sine A equals C over sine C. And then I'm going to fill out my thing. Okay? So just from what I was given, what I'm asked to find. So 7.2 over the sine of x is equal to 10.3 over the sine of 48. Okay. Yet again, we end up with a line equals line, so we cross multiply, just like before. So we get, what do we get, Luke? We get 7.2 times, and that's equal to 10.3 times sine x. Okay. We want to get x alone, right? So the way to get x alone is we get sine x alone first. So what's the next step here? Good. We're going to divide by 10.3. So I'm going to end up with something equal to sine x. I'm just going to go right into my calculator and type that in. Remember, your calculator follows the order of operations, so you can type in 7.2 times the sine of 48. You have to hit end bracket, and then you can go divide by 10.3 right away. Hit enter. We get 0.5194. Okay, continuing on. Is that what everyone got? 0.5194? Did you type in 7.2 times sine of 48, hit enter, and then hit divide by 10.3, and then enter again? Perfect. Both ways work. Okay. How do we get x alone now? Second sign. So you hit the sine to the minus 1, right? Now, I'm going to request something of you guys. You guys are getting old enough that you can actually follow your calculator's kind of instructions. You can own it. You can be a boss of your calculator, right? So we want to take all this number. So instead of typing all that number in, you're going to hit second answer. So you're going to hit second sine. That brings up sine to the minus 1. And then you're going to hit second with that negative sign way at the bottom here. Do you see that? You get the answer to pop up. Hit end bracket. Hit enter. So that angle measure x, that unknown angle measure, is 31.29 degrees. So if I scroll way up to this picture, angle A to the tenths, right? 31.3 degrees. Now, everything else, if you're going to solve for that other angle measure, you should carry all those decimals through. Okay? Still feeling okay? We solve for a side length, we solve for an angle using sine law. Okay. Let's do one more example together. Okay, solve for the following triangles. Solve the following triangle for all missing sides and all missing angles. I made changes here for a reason. Okay? Are yours changed? Good. So it says angle A is 43 degrees, side length A is 20, side length B is 24. Okay. What's the first thing you should do? Just draw a random triangle. We're trying to draw acute triangles, so a lot of times I just do a regular triangle that has small angles all over the place. I don't try to match them up or make them look like they are. Ready? And then I just label a triangle. So I could label this one as ABC. And then finally, I have to input what I know. So angle A is, so I'm going to write 43 degrees here. Side length A is, and side length B. So where do I put that in my diagram? So up here, which is 24 here. Okay? So we have to find, in this case, the first thing we need to find is angle B, because we have all of A and we know side length B, so we need to find angle B, right? Good call. So I'm going to write A over sine A equals B over sine B. And I'm just going to fill in 20 over the sine of 43 is equal to 24 over the sine of B. You could put x there, that's okay, but we can leave it as b because it's just a variable, right? So when we cross multiply, we actually get 20 sine b is equal to 24 times the sine of 43. What should we do next? Divide by 20 on both sides. Okay. So I'm going to pull up my calculator and do that. 24 times the sine of 43 end bracket divided by 20. Okay? So sine B is equal to 0.818. How do I get B alone? How do I get B alone? Second sine. So I do the sine to the minus 1. Okay? So on my calculator, oh, can someone do that for me? My calculator, where is that? Good. We're going to solve for C right away. Okay? So I have angle B. Are we good with that? 54.92. There's some decimals that carry along there, right? So I can come up here and put, what was it? 54.92, okay? You can round it in your answer, but when you carry it forward to find the other angle measure and to find the other side length, you should always carry all the decimals, okay? So in my answer, I'd write it 55, right? But it's actually 54.92, so this angle measure over here is 82.1, blah, blah, blah. We can write it as 82, But when we actually solve for this side length, we use 82.1 blah, blah, blah. Yeah. Oh, someone's throwing out Pythagorean theorem. A squared plus b squared is equal to c squared. What was c? A hypotenuse. And this is not a 90-degree triangle, so we cannot use Pythagorean theorem. So how can we find side c then? Good. I would use a because those are definite numbers, right? There's no extra decimals. So I would use a because it has 43 degrees and 20. Those are definite numbers. You don't have to type in a lot of decimals. And then we'd use c. C has that decimal 82.1 blah, blah, blah. At least it's only one decimal though, right? And it's in the bottom answer of our calculator right now too, okay? So we're going to use a over sine a is equal to c over sine c, okay? So a over sine a is equal to c over sine c. I don't like scrolling up, so someone tell me what side length a is. 20. And the sine of 43, is that what a is equal to c over sine of 81, 82.1 blah, 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 right? So now when we do this, what should we do? It's 20, it's line equals line again, right? So it's 20 times the sine of 82.1 dot, dot, dot is equal to c times the sine of 43. How do we get c alone? Divide by the sine of 43. Okay. Now, when you actually put this into your calculator, I want you to write 20 times sine, and then this 82.1, that's your answer, right? Right above, hit second answer, end bracket, and then divide by the sine of 43. We should get a side length of, sorry, just stop. Let's finish this question. 20. Okay. We'll work on some questions when we come in tomorrow morning, okay?